Welcome back to part 4. I'm sure you can probably tell that ScreenPal is not cooperating with me, so all of a sudden it'll just stop recording. Fortunately, it is saving these recordings, so I apologize for stopping. I left a note on the last video, hopefully you got it. The common error whenever doing heart rate reserve is not adding resting heart rate back in. That'll make more sense when I show you an example. Let me find out where I am. Okay, so when we are finding max heart rate, there are a couple of ways to do that. I want to make this a little bit bigger for you. The first is we can do a graded exercise test where we're measuring heart rate and then we increase the work rate for 3 minutes, and then we take heart rate and we keep doing that until we can't go any further, which is a graded exercise test, which I'm sure many of you are familiar with that. Well, that's how I get VO2 max. So the work rate when it's over is VO2 max, and then the heart rate, the highest heart rate, is your max heart rate. So the best way, not the best way, probably the most accurate way is to measure it using a graded exercise test. There's also the traditional way, which is 220 minus your age. For most of you, your max heart rate would be 200 based on that calculation. Understand that the traditional calculation, 220 minus your age, is only one standard deviation equals 10 beats. So it's plus or minus 10 beats. So it'd be 200 plus or minus 10 beats would be one standard deviation. And so there's another method, Tanaka et al., that tends to be a little more accurate for college-age males and females, and that's 208 minus your age times 0.7. And that's the method that I want you to use. However, on a test, it may ask you about the traditional method, which is 220 minus your age. I do ask one question, but I actually say what method to use. So just be familiar with the traditional, which is 220 minus your age, and Tanaka et al., which is 208 minus your age times 0.7. You multiply age times 0.7 first and then subtract that from 208. All right, so for percent of heart rate reserve, here's an example. So heart rate reserve equals heart rate max minus resting heart rate, or heart rate max minus heart rate rest. This is the same thing as this. It's just written in the nomenclature that we've been using for max values. Here's an example. JD has a maximal heart rate of 190 beats per minute and a resting heart rate of 67 beats per minute. So to calculate his heart rate reserve, you simply take 190 beats per minute and subtract his resting heart rate, 67 beats per minute. So you have a heart rate reserve of 123 beats per minute. This is the value I'm going to multiply and then add resting heart rate back in for my final answer. So I'm really factoring resting heart rate out whenever I'm multiplying by the different recommended percentages based on goal. Here's an example of that. So heart rate reserve, 190 minus 67 equals 123 beats per minute. We did this on the last slide. So the recommended amounts are 60 to 80% of heart rate reserve. That's the desired intensity when using the heart rate reserve method for the average person. 60% of heart rate reserve, I'm going to take the 123, multiply it by 60% and get 73.8 beats per minute. Listen, if I said I wanted you to work out at 74 beats per minute, most of you would already be there. So that doesn't really make sense. So then what do we need to do? We need to add resting heart rate back in. Remember I said this is where the error, common error occurs, but you won't make that error because I'm pointing it out. So 60% of heart rate reserve then is 140.8 or 141 beats per minute. Always round up your beats per minute since we can't take half or 0.8 or 0.8 of a beat. Let's do that for the high end of the range, which is 80%. So 80% of heart rate reserve equals 123. We calculated that first, times 80%, and that equals 98.4. Then we're going to add resting heart rate back in, 67 beats per minute, and we get 165.4 or 165 beats per minute. This is part of your individual training program. So knowing how to do this. So save this example. I actually have this PowerPoint for you, so you don't necessarily have to go back through my lecture to view this. So what's the relationship between percent heart rate reserve and VO2 reserve? You can see that there's a linear relationship because there's a linear relationship between work rate and heart rate, and the percentages are 60 to 80% equate to 60 to 80% of VO2 reserve. Okay? These are percents, not actual values. So 60, if I'm using heart rate reserve, 60, 80%. If I'm using VO2 reserve, 60, 80% is the average for most individuals. Well, here's a little summary. So the intensity spectrum for heart rate reserve or VO2 max. In general, most people, the recommendation is going to be 60, 80%. Now, I'm going to show you a slide in a little bit that's going to show you health related. It's a little bit different. And so for older sedentary population, you have 40 to 59% is the general recommendation. So this recommendation is one to remember. And then for younger, more fit, physically active individuals, it's 80% or above when using heart rate reserve or VO2 max. When using heart rate max, notice we use heart rate reserve and VO2 max here. Now we're going to use heart rate max. When we're using heart rate max, in general, we're going to do 75 to 90%. For older sedentary population, we're going to do 55 to 74% is the recommended range. And then younger, more fit, physically active individuals, it's going to be 90% or above. You're going to see some other ones as well. So the exercise intensity for improving cardiorespiratory fitness. In general, 40 to 50% to 84% of heart rate reserve or VO2 max. 60 to 65% to 90% for heart rate max, and then 12 to 16 on the original RPE scale, which is the Borg scale of